Okay, we chose to do experiment 9, which is determination of water hardness by complexometric titration. I'm Bill Leatherberry.
I'm Mike Berta. The objective was determining the water hardness from a sample collected from the lake. This is the picture of our lake that we collected the sample from.
Okay, water hardness is measured by the total amount of calcium, magnesium, and sometimes even iron cations that are found in the water. And this is caused from the limestone bedrock, which is at the bottom of the lake. And here's a picture of limestone.
The limestone contains a large amounts of calcium carbonate, smaller amounts of magnesium carbonate, and even smaller amounts of iron carbonate.
Over time, the calcium carbonate, they can dissolve in the water, and here's the equations that show that. For example, the first one shows calcium carbonate dissolving into calcium and then carbon trioxide, and the KSP values are shown below.
The solubility products are the equilibrium constants for these reactions and are given the symbol KSP. The KSP values favor the reactant side.
Water that has a high concentration of these cations is considered to be hard, and then the opposite is true. With low concentration is considered to be soft water. The American Water Works Association says that the ideal measurement would be 80 milligrams per liter, and that's the calcium, magnesium, and iron all together. In granite, there's literally virtually close to zero amount of those cations, and then with a limestone bedrock, it can exceed 400, so that kind of gives you two separate spectrums on the scale. And then the water here in Alliance is close to 380 milligrams per liter, which is pretty high.
Having hard water is not necessarily unhealthy for you, but it can be a nuisance. The calcium carbonate can build up in hot water heaters, pipes, and cookware. The buildup in the hot water heaters can cause high electricity bills, and it can also cause a water heater with a lifetime of average 15 years to down to below 5 years.
Soap scum is an informal term used to describe what happens when the water, when hard water mixes with soap. This can happen in a shower or in a sink, and it's a white residue that builds up, and it's virtually harmless to your health, but it can definitely be a nuisance. And a way that you can soften water is you could add a water softening unit, which pumps in sodium ions into the water, or you could use reverse osmosis to filter the water.
EDTA is good at binding to cations like calcium because of the 6 binding sites, and it also binds calcium at a 1:1 ratio, or the cation or the ion at a 1:1 ratio, and does so better than calcium carbonate.
Alright, so to start off our experiment, we used a 500 milliliter polypropylene bottle, and we chose a random spot at the lake to take a sample. We filled the bottle up about halfway, put the cap on it, and then shook it up for about 2 minutes, and then dumped the water out, and we repeated this process 2 more times. Once that was complete, we filled up the bottle completely, capped it, and then brought it back inside.
We put 4 samples of the sample we collected, 100 milliliters, into 4 flasks. Then we acidified it by adding 6 moles of hydrochloric acid, and then each sample was brought to a boil and then let cooled with a cover on it.
Alright, once it was cooled, we added a few drops of the methyl red indicator to each the sample, which made the sample turn a pinkish color. After that, drops of NaOH were added until the sample turned yellow.
We added 2 milliliters of the pH 10 buffer to each solution, and then a 0.3 gram scoop of urichrome black tea indicator. We mixed it by swirling, and then that should cause it to change red.
And we had a burette filled with the EDTA solution already, so immediately after we added the buffer to one of the solutions, we slowly added the EDTA to it until it changed from the red color to a bluish blue-green color. And once that happened, we recorded how much of the EDTA was used to let that happen, and then we repeated it for the other 3 samples.
This is our results table. The sample 2 was the best blue color that we got out of the 3 samples, or out of the 4. These are the equations of the reactions. That's the calcium carbonate and the calcium with the PDTA.
Okay, here's a sample of the calculations that we performed to figure out how much, how many milligrams per liter was in each sample. This is specifically our first sample, which ended up giving us 162.64 milligrams per liter of calcium carbonate. And here's a chart to show the two, the scale of different water hardness classifications. As you can see at the top, 0 to 50 is soft, and then anything greater than 450 would be very hard. Each of our samples were right in between 100 and 200, and then we took an average of each one, and it came out to be 134.28 milligrams per liter. So our conclusion is that our water was slightly hard.
And these are references.